Hello, welcome to another episode of Xan Talk Show. So today we are going to talk about walking a directory, programming language comparison of the task of walking a directory or list all file names in a directory. Okay, and we are going to compare Python, Golang, Emacs Lisp, and WolframLang. And I'm going to tell you a fundamental difference between industrial languages such as Python, Golang, C, C++, Java, and Ruby, basically all the popular languages you heard of, versus math-oriented languages. That would be Lisp and Wolfram language. There's a fundamental difference in how they approach the task. Okay, let's see. Video check, audio check. Okay, so let's begin. Okay, the programming language design: Python, Golang, Emacs Lisp, WolframLang, and PowerShell. PowerShell is a special case because it's a shell language, and in a shell language is specifically designed to list file names in a directory. So that's the easiest. Okay, so I'm going to do all these languages and demonstrate how to do that. Okay, hello Immortality, and hello Tridius. Okay, so as a programmer, you have the question, which language is the most should you learn? Like how easy, how complex it is, how powerful, how fast it is, how elegant it is. You are hitting the right spot. We are going to do comparison, of the language design. This is language design, an issue of language design of the this Python, Golang, Lisp, Wolfram language differences in PowerShell. Okay, so in terms of easy, which one is the most easy to do for programmers? That would be PowerShell. That's a special case because it's a shell. It's designed to list directory file names. Okay, so for example, you are looking at PowerShell. Okay, so you are looking at PowerShell. So let's magnify. Okay, let's do it again. Clear screen. Okay, that's list all file names. Let's go to web. Okay, let's go to Sali info. Okay, and let's go to Emacs directory. Okay, so let's do it again. And now the recursive and files. Okay, we only want files, no directories. Okay, so huge number of things. Now so this is how you walk a directory. Meaning that you want to, for example, you want to change file, you want to refactor your code. You want to find some pattern in each and every file, JavaScript or C# or whatever, C++. You want to refactor. So you want to find the pattern and you want to do replacement. So in order to do that, you need to walk directory or get the list of all file names in a directory. Same concept, but different names. So you see, here comes the conceptual differences between mathematical approach versus algorithmic approach, which is most in the industrial languages. Because from a mathematical point of view, what you want is list of file names. That's all you want, a list of file names. Then you can have a function to loop through each and every one and do something to it. This is mathematical approach. What you want is a list of file names. On the other hand, Golang, JavaScript, Java, they don't do it that way. They don't have a function list file names. Okay, let me close the door. So in these industrial, non-mathematical languages, their approach is walk the directory or traverse the directory. That is, you have a function named walk. Then it's fairly complex. Then you have to provide a function that each time the walk function finds a file, it passes arguments to your function. This is complex. Okay, but let me finish demonstrating the PowerShell. Okay, so PowerShell recurse file, and let's say filter. So we filter. Okay, most of the time you want to filter HTML. So this is a list of all just HTML files. Okay, now let's try PNG. So all PNG files or JPEG files. Okay, and let's say you want the full name, the full path. So what you do is you pipe it to full path. Okay, for each that percentage sign is an alias for each object. Okay, so that's what we do here. Then $_ means the current object dot full name. Full name is a property. Okay, so now you are looking at the output that's familiar to most Unix people, just the full path. The PowerShell, this is annoying. They list the directory name, then in that directory they list each. That's kind of annoying because every time you need to go through, anyways, that's another detail. So this is how you do it. Okay, so this is in PowerShell how you list all files in a directory, or how you walk a directory. Once you got this is the syntax, then you can pipe it to whatever and do something. For example, we pipe it to for each. Let's use the full name instead of the percentage. You can just say for each object. That's a full name, same thing. Okay, so let's expand this. Yeah, so this is how you walk a directory in PowerShell. Now let me show you another thing. Okay, so now this command dir is a alias to the full name get child item. That's the style of PowerShell. Instead of ls or dir, you have the full name get child item. So for example, we can say get child. It's exactly the same. Okay, so this command get child item recurs file filter. It returns a collection. Okay, actually, so technically speaking, if you want to turn this into an array, you put a @ sign, then parentheses. So now it actually returns an array. So how do you know? Well, for example, now you can. Okay, so this is getting technical detail. So you can say get member and input object to be that. Then it'll return and it'll tell you. You see, it is a array of system.object type. Okay, so anyway, so this operator @ sign is called splatter operator in PowerShell. It turns a collection of things, which is this get children returns, it turns them into an array. So this is once you got an array, then you can call whatever function. In PowerShell you don't actually need to change it into an array. You just like we did before, you just directly pipe into something, then start to call a function on it. But sometimes if you do need an array, then this is how you do it. Okay, splatter operator. Okay, let me show you because I just updated in my blog PowerShell array collection to array. So this page explains how this syntax is. Okay, so anyway, we are digressing a little bit. Let's get back to traversal directory. Okay, so PowerShell, one single line does it. Okay, now next let's look at Wolfram language. Okay, Wolfram language, this is the second easiest. Okay, simple in concept. Now pay attention to how simple they are. We are comparing language design. Pay attention to what approach and how easy they are. Okay, now Wolfram language, here is Wolfram language. Okay, so basically you have the function file names that will list all files in the current directory. Okay, then you can pass a argument, which is a pattern. The pattern can be a regular expression or wildcard. Then it'll filter out by those patterns in the current directory. Then you can give a list of patterns. For example, you want JPEG files plus JPG or JPEG or PNG. You have several. So you can give a list of patterns that will filter them out. And then you can give two arguments. One is a pattern or a list of pattern. The second argument is a directory for a specific directory, okay? And then you can also give a list of a directory. Now this part, all the languages cannot do. In PowerShell, you cannot do. In Unix, Bash, ls, you cannot do. If you want two different directories, you have to actually do a for each on different input directory. But in Wolfram language, it's one single function. So you can have list of patterns, and you can also have a list of directories. I'm gonna demonstrate, okay? Then you can have add another argument. That's the depth, okay? So the depth can be infinity. So typically in other languages, you just say recurse. Recurse. In Bash, in Unix, in Linux, it's -r. So, but in Wolfram language, it doesn't. It's not like that. The third argument is just the level, the depth. Okay, so you can actually say infinity. Okay, let's demonstrate. Wolfram language. Okay, let's go to Emacs. Okay, so wait. So let's start Wolfram. Okay, and let's pop it out. And file names, okay, completion, okay, then let's say a pattern, wildcard, HTML, okay, then which directory, let's say I want to list, just like in PowerShell, Emacs, I want to go list Emacs directory. So where is my Emacs directory? Copy the name, there it is, okay, Emacs directory. Then the third argument is a level, okay, so let's say infinity. Okay, so this is how you do it. Okay, so we can run it. I'm right now in Wolfram mod. Okay, so this is open source. You are looking at the source code. And here's a URL, open it, show in browser, so you can go there, you can download it. This allows you to run Wolfram language in Emacs, okay, and it's on GitHub, so you can just download it, it's free, okay, it's sponsored by Wolfram Research. Okay, so let's demonstrate, okay, so close that, Wolfram mod, let's run this, okay, run it. Oh, it's gonna be huge. When you have, so here, the negative of infinity expected. Oh, I got a syntax error. Let's do it again. This is going to be huge. You see, here is a result. It's one huge long line and when you have, this huge long line, Emacs cannot handle it. Becomes very slow. Okay, so let's close that. Okay, so anyway, let's run this in Wolfram script. Okay, so same thing, magnify. So let's start Wolfram script. Okay, now do it. Okay, so paste. Okay, so in Control-Shift-V. Okay, in Microsoft, there it is. Control-Shift-V. What? Control-V. Now, how do you paste in terminal? I forgot. I don't have the insert key. Usually Shift-Insert, I think, or Control-Insert. Oh yeah, okay, right-click. So there it is. So you do it. So you got all HTML files. Let's try again. Now let's change the pattern. Let's say PNG. Okay. So you got all PNG files. Now let's say we want a let's modify it here. It's much easier. So we want a Okay, so we want a list of let's say TS, and TS is TypeScript and JavaScript. Okay, copy that. Paste it here. Oh, you cannot paste, right click. Okay, there it is. A list of JavaScript files and TypeScript files. Okay, so let's do them here. Let's do them. So if you want a list of JavaScript or TypeScript, you have to do include this time. So star JS, comma, star TypeScript. There it is. So that's how you do in PowerShell. PowerShell and Wolfram language, fantastic. Okay, so this Wolfram language also provide a directory level, so you can traverse, depending on how, the depth. Okay, that's PowerShell, and that's Wolfram language. Now notice their command name, file names, and in PowerShell it's get children. So for example, help the, you can see the full name is get children, get child item, and in Wolfram language file names. So they basically essentially return a array of file path. Okay. Now what you so these are math oriented concepts. So you see they do not involve a time concept. So get children, it just return an array, a list of things, and same thing with the file names. Now let's look at Python. Okay, so today's talk show. Now let's start to look at Python and Golang. Now this will be very complex. Okay, now so in Python, when you want to get a list of directories, so you have to call os walk. Okay. So how do you, I haven't coded this for a while. So wait, let me see. Wait, where does it pass the function? For each the visit, so os.walk, for each the visit starting with input path, os.walk returns a generator, a list-like thing, a generator where each element is a tuple of this format. Okay, so you have the full path of the directory, sub the name list, and file name list. Okay, then wait, where is the function you actually call? Okay, so in Python, yeah, so this is how you do. Okay, so it's a bit complex because it returns a list. It returns a generator which is like a list, but unevaluated list. Again, that's a concept from algorithm, not mathematical. Because basically, when you have algorithmic type of concepts, you have the concept of time. So generator is such example, which is very popular. Am I still going? Say hi, okay? Say hi, guys. So generator is, again, the concept of generator is very typical in industrial languages such as C, C++, Java, C#, Perl, Ruby, Python, they, in JavaScript, they, generator. So what is a generator? Generator is actually just a list, but it's like unevaluated list. So you see, it involves a time concept. It's not mathematical. For example, so what is mathematical? In contrast, for example, if you want to do sine, cosine, sine something, you don't say sine some number, you don't say, well, return something, return a time series, then you have to call another function to get each term. You don't do that. It simply returns an answer. Okay, ask something, returns an answer. A function always returns something. So that's mathematical. But generator is a prototypical, a classic example of this industrial language is no good. Okay, it's not good in many ways. So it returns a generator, a list kind of thing, where each element is a tuple, is three things. Okay, so okay, let's demonstrate the Python. Okay, so let's do it. Okay, it's same thing. So Python, let's see Python 3, paste the code here, pop it out, and the pink window shows all my command calls and keystrokes in Emacs. Okay, so I want the Emacs directory. So Emacs directory. Okay, so yeah, so the Python, well, so this is how you do it. Okay, let's run it. There it is. So there it is. There is all the files in that directory. So you have JPEG files, you have PNG files, you have HTML files. Okay, close. Now, what if we want to filter? You know, let's say we want JavaScript files. So you have to code. You have to code it. So how do you do it? Full path OS join. Okay, the file name. So you have to check if the file name match a particular pattern. You know, so the point is, you see, it's starting to get tedious. This is not as easy. Okay, do I have an example here? No. So okay, the easiest way is just look at my existing script. Okay, so let's do that. So basically, we want to get just the, you know, file with a particular file name extension. Okay, so let's go to replace. So this is my Golang replace command. Let's drop to the directory. So this is the so let's search for Python. So yeah, Python, and here is my script to traverse the directory and do find. Okay, this is like grep. So we want the file name pattern. So where is it? Level file name with no change. Wait, where is the? Oh, I don't have the pattern separated out. Yeah, I have the pattern here. So yeah, God, I have to do that. So here is the filter here. You know, you filter out by regular expression. You want all HTML files. So what we need is we need to copy these lines and put it here. And the Python is okay for file name, for f name, for so oh, we already have it here. Okay, so hold on a second. Full path. So for file name in the list. Okay, so we don't need that. How do we? Oh, tab is not defined. Okay, in Emacs I redefined tabs, so I don't have the tab key. Oh, okay. So anyway, so let's see. Let's just say that Python very annoying, you know, because the indentation. Let's just say one. Okay, so that. Okay. Then what is check file? Don't check file, just print it. I think that will do. Okay, let's run it. Run it. Error. Name re is not yet defined. Okay, so you need to import re. That's okay. Let's do it. Okay, now we got all HTML files. Now let's change the regular expression to JavaScript. Run it. Okay, so we got all the JavaScript files. Now we want a JavaScript or TypeScript. Okay, so copy that. So we want a alternative TS or JavaScript. Okay, so actually let's try that. There it is. So that's how you do it in Python. Okay, so pop it back, syntax correct, show in browser. So we have the code, Wolfram language and Python, okay, and PowerShell. So you can see, so there it is. So my point being that, you know, in Python you have this work concept, work directory, which is, no, actually in Python you don't have the, yeah, so Python work os.work also returns a list basically, but it's more complex. Okay, so now let's move on to Golang. Okay, now Golang is actually the most complex. Golang is quite complex, and it actually involves a time concept. Actually in Python it also does, I think, because in both in Python and Golang they changed their work directory function. So you are looking at Python 2's work directory, which is different. Yeah, so there it is. So that's my point. So this is a good example. So Python 2, so let me explain. Okay, so Python 2, sometimes around 2018 or so, Python created a new work directory function. So in Python 2, you have os.path.work. Okay, in Python 3 and also Python 2, basically they created a new function, os.work, and these two are completely different design. Okay, so in the old one, os.path.work, you give a base directory, then you have to give a function, then argument. Okay, so this is the actual concept of working a directory. So once you call it, you know, then it will call the function f every time, you know, it gets a new file or directory. Then your function f, you have to write the function f then to determine what to do, whether to quit, you know, whether to abort, quit, or do something. So this design of worker directory involves a time concept, because every, you know, it doesn't just return a thing. Every time it does something, it calls your function. While the Python 3 version doesn't do that. It's simply this os.work. It doesn't actually work. It simply returns a whole list. Okay, so this is better. This is much better. Okay, Python 3. So two designs. Now this os.work is also in Python 2. You know, they added to Python 2. So in the Python 2 version, it's more complex, but the Python 3 version is much better. Now let's look at Golang. Now Golang is similar to the design of Golang's work directory is similar to the Python 2 version, such that, you know, it takes a directory, but it also takes a function, and every time it sees a new file or directory, it'll call your function. So Golang work directory much more complex. Okay, so Golang, you know, in Golang version 1, you have the path /filepath.work. Okay, so you can see example here, fairly complex. Okay, so here's a full code. So in order to do that, this is a full code to run it. Now, in about 2 years ago, Golang 1.16, they created a new function to worker directory, which is workdir. You know, the name they added the, and this version is basically the same as the old version, except it's faster. Okay, so they try to improve it, so they create a new version. So this version is faster, but the design is essentially basically the same as the old version. So the new version, they just improved speed basically. So again, so let me so Golang is more difficult, no, fairly more complex. So the worker, it takes two arguments, okay, the directory path, the starting directory you want to dive into, and a second argument for the function you have to write. And because Golang is a typed, statically typed language, so the function has a spec, it takes three things and returns a error object. So okay, I'm getting probably boring. So let's what we do now. Let's run it. Okay, so let's just run it demo. So copy the code. Yeah, let's demonstrate the Golang version. So here's our versions. Paste the code, pop it out, so we can actually code it. And we need the Emacs directory. So here is the directory. Okay, then go through the directory and print all file name and extension. Okay, so if we just run it, okay, so there's a lot. It prints lots of things. It prints the directory, prints the file name, and prints the file extension. Okay, so we just want, let's start printing all this. Let's just print the file name. Okay, run it. Okay, so it prints the full path and then also prints the file name. Okay, redundant. So let's even not print that. Run it. Okay, now it's just a list of full path. Now suppose I want to filter them out. Okay, so is it don't print nothing. Can we run it? Okay, good. So now we want to filter the name. Okay, so we have to filter the name. Okay, so now we need a regular expression. We need a regular expression, rejects here if match .ts or .js, then print it. Okay, you need a regular expression. So how do you do that? Let's go to Golang and let's go to regular expression. Okay, so okay, here is a tutorial. Now Golang's regular expression is fairly, Golang is a low-level language, so every time you need to do something, it's tedious. So regular expression must compile. What is this I? Replace string we don't need. Now regular expression, let's say \.ts or js. Okay, so that creates a regular expression object. Now I don't need to replace. I need to check if it matches. So okay, so I don't know what's the function for match. So let's look at Golang documentation, turn JavaScript, match. Golang back to the 80s. Golang is pretty good though. Golang is simple and fast. I mean, for low-level programming languages, I think Golang is great. So you have so many functions, you know, Golang. There's a bad point about Golang is that you have a regex function for, you know, for string or for byte slice or for run slice, which is Unicode slice characters. So you have like a variant for each one of them. So anyway, so which one we want? We want the match. You know, so if you look at the Golang functions for regular expression, it's more. It's like 5 times more than Python's regular expression functions. Python has maybe five or 6. Golang has like 30 of them. So okay, which one is the one we want? Basically, we just want match. Okay, so match string, match reader, match. Okay, let's try. So it takes a byte. Okay, anyway, this is too complex. You know, the easiest way again is to look at my Golang script I have already written here, Golang. Okay, so file name regular expression, there it is. Just search for that. And oh yeah, so that is the function we want. Okay, so let's copy that and let's paste it here. So what is the regex? Regex is the okay, so we need a regex package. Do we have it? No. Okay, so we need to load it. God, tedious. So now we have the regex package. So this is our regular expression, and then match file name regex. Okay, so that's the file name regex. Okay, we want to match that. Then we want to match the file path, x path, okay, which is the x path. Yeah, so base, no, we don't care about base. Okay, so if that returns true, then if x is true, then do that. Maybe let's compact. Let's pretty print our code. Let's hope it runs. Okay, run it. Okay, declared and not used. Golang. What? I have a brief. Let's see. Golang mod. Now I have a brief for error. So let's see. IE. Okay, if error. So this is yeah. So you need to add that. Okay, if error panic. Let's run it. Yeah. Cannot use file name regex variable of type as a type string. Okay, so let's so instead of that, let's just say a string. Okay, comment that out. Instead of a regular expression object, let's just pass a string because this function requires a string type. Let's run it. undefined result. So where did we, okay, so here we need to print XPath. Run it. Okay, so remove this. Okay, run it. Fantastic. Okay, so there it is. It got extraneous results because we forgot in the pattern we need to say it must match at the end of the string. Okay, do it again. Fantastic. So that's how you use Golang to list all JavaScript or TypeScript files in a directory. So let's do it again. PowerShell clear PowerShell. There it is. Okay, PowerShell. Wolfram language. Okay, so pop this back. Now Wolfram language. There. Okay, so let's go to Wolfram language. Pop it out. Basically that's the code. Copy it. You can download Wolfram language free. Okay, just go to my website, Xali Wolfram language. You can find the download location. Okay, so this is how you do it in Wolfram language, a list of JavaScript or TypeScript files. Python. Run it. Fantastic. Okay, this is how you do in Python. Now, what if I want the full name? Okay, so let's see. I want the full path. Okay, maybe that. Do it. There it is. Okay, Python. 10 lines. 5, 6. How many lines? 1, 2, 7 lines. Okay. Now Golang. 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 Let's remove the comments and stuff. And what is this part? We don't need. Let's remove the things we don't need. Okay, so basically this is Golang. 40 lines basically. Clean the code. Yeah, 40 lines. Run it. There it is. There it is. Okay. So I think that's it for today. Hold on a second. So color syntax color it, show in browser. So this is today's talk show. We went over these languages and language design, and we talked about the difference between math-oriented language and industrial languages. So, we missed one thing. We missed Emacs Lisp. Now, Emacs Lisp is another math-oriented language, just like Wolfram language. So how do you do it? Here, okay, this directory and also directory. Okay, let's just copy it. Let's do it here. So we have WolframLang. Let's put Emacs Lisp here. Okay. Now we need the directory. Okay, so pop it out. So the directory will be there. Okay, and let's make it this. Okay, so let's run it. So okay, so we don't want to insert. So basically here is the code. Okay, so and the regular expression should be TypeScript, or that's what you have to do in Emacs Lisp / toothpick syndrome TSOJS. Okay, run it. Done. Okay, so yeah, it just returns. It doesn't do anything. So you have to actually run it. There it is. So okay, so it returns a list. So if you copy the list, new buffer, paste it, and wait, break the line into each, break the long line, then you got that. That's how you do it. So okay, close that, no save, pop it back to browser, syntax correct, showing browser. So we showed several. So you see, here is Emacs Lisp, one single line, and here is Wolfram language, one single line. Okay, they are very similar. Let's remove the comment. Emacs Lisp, one single line, Wolfram language, one single line, and very similar in design. These are math-oriented languages where you do a function, it returns results. Okay, there's no concept about time. Okay, function return result. There's no time involved, or how the traverse, you are traversing something. Nothing. Now in Python 3, it so you have the walk the this is where is the function name? Walk the function. So again, it just return a list. But in Python 2, it's more complex. And then we have the Golang. Then you involves a walk function that calls your function. Each time it gets a path, it calls your function. So walked or traversed, this involves a time concept. Okay, I think that's it. That's what I want to say about this. The important thing I want to say is the math-oriented design concept versus the algorithmic concept, because mathematics is about what is. There's no concept of time. There's no concept of how to do it. There's no concept of step by steps algorithm. It's just what it is. You want a list of file names, you get a list of file names by a function. While most industrial languages, Python, Golang, C, Java, you have a walker, and each time it runs, each time it finds a new file or directory, it calls your function. So that's my point in language design. Okay. Pathlib module. Okay, so that's yeah. Okay, that's I don't know about that module, but I suppose that's it's you always have you could also write this function in in Golang. You can write a wrapper so that you can have a single line that returns a list of files, but it's not the standard normal way. So new in version 3.4, this module offers classes representing file system path. Okay. Whatever, Python documentation is always pretentious, and so how do you do list subdirectories? So path equals to path dot. So this is an abstract representation of a path. Then you have a list comprehension idiocy, which is a special special syntax within the Python language that generates a list. Then you have the concept of generators and iterators that deeply, that's a prototypical example of time-based, concept in programming languages. So for x in that iterator, if x is a dir, so okay. So what if you want to list match by a regular expression? So I suppose you just if match. Okay, anyway, that's interesting. So that's it for today. I think that's it. Okay, bye guys. Who you guys watching, say hi. Okay, so if you like my stuff, buy my stuff. Okay, buy my stuff. You can. So I have this Kinesis Advantage keyboard. It's fantastic. Let's go to, I'm gonna shut down in 1 minute, in 2 minutes. Okay, so what is the latest writing about keyboard? Yeah, that's it. I'm gonna have a drink. So 15 minutes. So So keyboards. So again, my keyboard is this one. That's the one I'm using. And the one on top here is this Ultimate Hacking. This one is great for key macros, the best interface. The best interface, where is it? For keyboard macros. Expensive though. This one is expensive. I wouldn't say so. I wouldn't say this one is so great for, if you just buy it for typing. And also, this seems, also if you just want a keypad, there are programmable keypads around, so you can buy one of those. But I happens to have Happy Hacking, so I'm using it for as a key macro, and there's a separate, there's the other side over there you cannot see. So anyway, and my recommendation, best keyboards are these. So Kinesis Advantage 2 and Expose and Kinesis Freestyle Edge, very good. Or the Misto Barocco, all these are good. I mean, others are good too, but if you are gonna ask me which are my favorite, that would be those. Depending on different needs, for example, this one, I think it's great, but it's over $500, too expensive, and also it's hard to buy. It's from Japan. Ultimate Hacking, it's a bit expensive, and also I want full function keys. It doesn't, so I mean, compared to price and all other things considered, you make different choices. And keyboard I/O is, I'm not sure I want to spend, $350 for this one if I'm gonna spend $350. And there's Moonlander. This one is pretty cheap, and pretty functional, practical, so different keys. And okay, so if you like them, buy from my Amazon and support me from Patreon me, Amazon gift card me, and PayPal. Okay, and buy my Emacs tutorial. Pay me basically. Emacs and my Emacs tutorial and JavaScript tutorial. Where is it? These two are my best tutorials. Okay, so that's it. So anything else? Let's close that. Okay, that's it. So keyword block, let's close. So today we covered all these. Fantastic. Okay, that's it. Bye.